Welcome to Narayan Microwave Technologies.
This is the demo of series and parallel resonance circuit trainer model KMS204. As far as hardware part is there, on this board you will be getting one sine wave with amplitude as well as frequency adjustment pot, so that you can vary the amplitude and the frequency of sine wave output. Now in this part, means in this kit, you can perform the experiments series resonance as well as parallel resonance. Here you will be having the series, and here you will be having the parallel resonance circuit, and these two parts are used for RL in series or RC in series, whereas in this part you will be having RL in parallel or RC in parallel. So, and this kit has inbuilt power supply, and at the rear end of this kit you will be having the 3-pin AC socket along with the on off switch. Here I have made the connection of series resonance circuit. The connection is something like the sine out of the sine wave generator goes to this input of RLC series circuit, and ground of this sine wave goes to the ground of this circuit, and here across R value you will be having the output waveform, and I have used this DSO. The first channel goes to the sine out, okay, and the second channel goes to the output circuitry of the RLC series circuit. Here this is on off switch. Now I am making it on. This power LED is there, and you can observe the waveform. This one is our input, this one is our output, and by using the frequency adjustment pot, first you have to put this amplitude adjustment pot at some point and leave as it is, and by varying this frequency adjustment pot you can observe the increase or decrease of the amplitude of the output waveform. Here I am increasing the frequency adjustment pot slightly. See, you can observe the amplitude of our output waveform is getting increased at some point of time. It reaches the peak value and then decreases. So to calculate the resonant frequency, you need to find out the peak amplitude of output waveform. This peak value, that would be your, see, this is our maximum output or maximum amplitude of our output waveform, okay. And you can also observe the frequency at which you will be having the maximum output, that is around 2.9 kilohertz. So the resonant frequency for RLC series is 2.9 kilohertz. That can be verified by using the formula of the series resonance circuit. So you can verify it by using the formula, the theoretical value and the practical. So this is your series resonance. For parallel resonance, only what you have to do is you have to use this parallel circuit. So you turn it off first, connect this to here, this one is here, this is your ground, this one is your output, and put this frequency adjustment pot to minimum position and turn it on. Here you will be having some waveform. Okay, in the parallel resonance, if you increase the frequency, your amplitude starts decreasing, and some point you will be having the minimum amplitude of the waveform. I am decreasing it. I am increasing the frequency. See, this is your. See, if I keep increasing further, your amplitude starts increasing again. Now I am getting in reverse. So to calculate or to find out the minimum amplitude, this would be your minimum amplitude, near about. Okay, and so at which you will be having the minimum amplitude, the frequency would be your resonant frequency for parallel resonance. Here you can see it is around again 2.9 kilohertz. That is your resonant frequency for parallel resonance circuit, and that also can be verified by using the resonant frequency formula. That will be 1 divided by 2 pi RC. So you can use the component value. The component value has been given, R and C value, so you can calculate it and you can verify it by your measured value and the theoretical value. So that can be verified by using the kit.